Hello students, we're gonna close the chapter exponential today, and the contents of today's topic will be exponents, laws of exponents, rational exponents, algebraic expansion and factorization, and exponential equations. We are going to use many words today as our vocabulary of today's lesson. Words like exponents, powers, indices, degrees, adding, subtracting, multiplying, dividing. Now, as we told in previous lesson, what is an exponent? We talked about the base and power index or exponent or power. So rather than writing again and again, like multiplying 3 or any number, writing 6 times, 7 times, or 8 times, we rather use a degree, right? We can write this product as 3 to the power of 5, or we say 3 to the exponent of 5, or we can say 3 raised by 5. So here it tells if n is a positive integer, then a to the power of n is the product of n factors of a. So rather than writing any number n times, we write a to the power of n, or a to the exponent of n. We say that a is the base and n is the exponent or index. Now let's talk about negative bases. A negative base raised to an odd exponent is negative. See, negative 1 to the power of 1 is negative 1. A negative base raised to an even exponent is positive. You see, negative 1 to the power of 2 equals to positive 1. Let me answer to these questions. List the first 6 powers of 2, 3, and 4. The answer will be 2 to the power of 6. 6 is 64, right? Am I correct? 3 to the power of 6 will be 729. When I multiply 3 6 times, I get 729. And when I multiply 4 6 times, I get 4096. Copy and complete the values. 5 to the 3rd power, we can say 5 to the 6th power, or 5 raised by 6, or 5 to the exponent of 7. There's many options that you can use when speaking about powers, right? So 5 to 2nd power is 25. We already know that 5 to the exponent of 3 is 125. For example, 6 to the power of 2 is 36. Let's move into laws of exponent. What kind of laws do we have? When we multiply numbers with the same base, we add exponents. We add their exponents. When we divide numbers with the same base, here, a to the power of m divided by a to the power of n, we subtract their exponents. When we raise a power to a power, for example, a to the mth power raised by n, we multiply both exponents. Now, the power of a product is the product of the powers. Like ab in the brackets to the power of n will be distributed like a to the nth power multiplied by b to the nth power. The power of a quotient is the quotient of the powers. A divided by b to the nth exponent equals to a raised by n divided by b raised by n. Any non-zero number raised to the power of 0 is 1. So any number except 0, when we find the exponent of any number except 0, to the power of 0, it will always be equal to 1. Even 1 million to the power of 0 will be equal to 1. And now the important part is a to the negative nth power will be equal to 1 over a to the power of n. So such that we get rid of negative power. Examples: simplify using the exponent laws. A, 3 to the power of n multiplied by 3 to the power of 4. Look, they have the same base, 3, so we add their exponents 5 plus 4, we get 3 to the power of 9. For example, division B, 5 to the power of 3 divided by 5 to the power of 5. We subtract their exponents, 3 minus 5. It will be negative 2. So we get 5 to the power of negative 2. We can write it as 1 over 25 because it equals to 1 over 5 to the power of positive 2. Example of power, 2 power. M to the degree of 4 raised by 3. Here we multiply both exponents. 4 times 3, it will give us 12, m to the power of 12. Skipping to the rational exponents, the exponent laws used previously can also be applied to rational exponents, or exponents which are written as a fraction. Now look at the example, a to the power of 1 over 2 multiplied by a to the power of 1 over 2 again. Here we add their exponents, 1 over 2 plus 1 over 2 will be 1. A to the power of 1 equals 2a. We used here first rule of exponent laws. So we have to remember that a to the power of 1 over 2 equals 2 square root of a. Like here, 1 over a to the power of 1 over 3 will be equal to cubic root of a. So we notice that in general a to the power of 1 over n will be equal to nth root of a. Here we can see how we read this term. It reads as the nth root of a. Where in other places do we use exponents? Algebraic expansion and factorization. We can use the usual expansion laws to simplify expressions containing exponents. So these are the equations from 7th grade. We put out of the brackets like terms, like in the first example, a multiplied by the sum of b and c equals to, using distributive law, ab plus ac. Like in the third equation, it is a formula. A plus b multiplied by a minus b gives us a squared minus b squared. So here we can see exponents as well. Let's look at the example. We have to expand and simplify this equation. X to the power of negative 1 over 2 multiplied by the sum, not the sum here, multiplied by x to the power of 3 over 2 plus 2x to the power of 1 over 2 minus 3x to the power of negative 1 over 2. So what we do here, we open the brackets and we multiply and distribute x to the power of negative 1 over 2 to each term of this polynomial. So we open the brackets, we simplify, we get x to the power of 1 plus 2x to the power of 0 minus 3x to the power of negative 1. Here you see they wrote here each term is multiplied by x to the power of 1 over 2 and adding exponents. Because as the exponents law says, we add exponents when the bases are the same. In example 14, we factorize given equations. For example, 4 to the power of x minus 9. We can write 4 as 2 squared and 9 as 3 squared. So we get 2 to the power of x plus 3 times 2 to the power of x minus 3. Interesting part, exponential equations. An exponential equation is an equation in which the unknown occurs as part of the index or exponent. So unknown part, variable, is in the exponent place. So we have to find the power, the exponent of this term, the equation. For example, they might give us 2 to the power of x equals to 8 and ask find x. We know that 8 is 2 to the power of 3, so we equate the exponents and we can see x is equal to 3. And this is the only solution. If the base numbers are the same, we can equate exponents. This is a very important thing. If a to the power of x equals to a to the power of k, then x equals to k because we equate exponents.